Due to time constraints, we were not able to have the whole series for that day. So we took out time, and with his generosity, he made out time for us to continue and complete the series on pixel-based image analysis. So today we'll be having the practical session from a follow-up session, let's say an episode 2 of the theoretical part we had on the 13th of February. So hello, Ajibola. Thank you for giving us your time to complete this series, and we appreciate your presence here with us.
Okay, thank you so much. Hello, can you hear me?
Yes, I can hear you. You have the floor.
Okay. Oh, okay. So, good evening, everybody, once again, and it's so good to be here once again, and all thanks to the Special Data Science Society of Nigeria. So, they've introduced me already. I'm a recent graduate. I'm Ajibola Alade, and I'm a geospatial data analyst. So, the last training we had on this topic was pixel-based image analysis, and I showed us how we can use pixels to how we can use pixels in spatial data just to achieve what we want to achieve. So how we can use pixels in spatial data to achieve what we want to achieve. So we'll be continuing from there. Everything we did that last class was just theory. Basically, I was just explaining to us, but now we would see a practical use case, of how these pixels works in spatial data. It's when we see it, that we can believe it. But definitely. Definitely, we cannot um we cannot check all the applications. But then if I show us one, okay, let me share my screen and share the previous slide so that, sorry, Miss Rikia, you have to enable me to share my screen. Yeah, so like I was saying, it is when we can see one use case, definitely would be able to see other use cases too. So like I said, time will definitely not permit me to be showing us all the use cases of pixels, but then let's just look at one, and through your own personal practice too, you'll be able to do the rest. So let me just share my screen and show us um some of the use case that we discussed the last class. I hope you can see my screen now. Yeah, please let me confirm.
Yes, we
Have you,
can.
okay, so the last time, that was February 13, we went through pixel based image analysis. Then we look at pixels. So we'll be seeing an example of a spatial data and how those pixels works, like how they work in the spatial data. Like I said, pixel are small units. We discussed all these. Then the binary grayscale, we'll see the RGB too. What we mean by RGB, I'll show it for us. We'll see the multispectral, so different kind of spectral bands too. Then we'll be looking at pixel transformation too. Then we'll be looking at some analysis. Now we're basically discussing the um, image classification basically. So we have different types. I'll show us too. Then this is my main concern now, talking about the practical applications. There's land cover, we have vegetation health monitoring, urban expansion. There are lots. There are a lot, both in remote sensing, in agriculture, in environment. Talking about agriculture, we'll be using the spectral bands. We have in even in medical. Basically they are just what we can use these spatial images to do, using those pixels, because the origin of those images are the pixels. So that's why we must know how to use them and how to manipulate them. So like I said, we'll be using some tools. Definitely we'll be using our ArcGIS Pro, and some tools that we've also embedded in the ArcGIS Pro for us. So we'll be looking at it too. And yeah, so I'll show us how to load the image, how to manipulate, then how to analyze the image, and how to visualize it finally. So I think that was a quick recap of what we discussed in the last class. So not to take too much of our time, let's move deep down to the practical session. So I hope you can see my ArcGIS Pro. Please kindly confirm.
Yes, it's visible.
All right, so let's move on. So basically, I have the data here with me. So we'll be using the Landsat 8 data basically. Although I have the Sentinel 2 with me here too. So if it's also the same practice basically, using the Landsat, using the Sentinel. But like I said, I mentioned it in the last class that one advantage of using Sentinel is that it has much more higher resolution. But then for the basics and for the basics, let's start with Lancer. Then as we progress, you also know how to use Sentinel for this kind of analysis. So I have here with me. Okay. So let's start from the basics. This is Lancer data, and someone can ask that how did I get this Landsat data? So the last training we had on 3D, our facilitator took us to this website, which is USGS. Yeah. So the same way he downloaded the DEM, the digital elevation model from USGS. So that's the same way we can also download a Landsat image also from USGS if it is Sentinel. So this is the USGS platform. If it is Sentinel, you have to use the Copernicus platform. Yeah, the Copernicus data space ecosystem for Sentinel. So this is that. So we can further explore the website. So this Copernicus, you just come to explore data here. That's if you want to get the Copernicus data. But for Landsat, you can get it on USGS. So same process too. We just come to this data layer, change it to SG World imagery. Although I've downloaded the data, but like I said, just to show us how to download the data basically. Yeah, so then okay, then I can use the address method or the pattern row method. Okay, so if okay, let me just use the address method. So any address you want anywhere in the world, just type it in. Let's say for example, I need a place in Lagos, Nigeria. I'll click it there. Then I'll come to show. Yeah, so it's here already. So it's going to take me to that point. Then okay, so where and I want to focus exactly in that particular area, then I'm going to draw my polygon on it. I'll just right click. So let's say this is the area that I want to get. It's already showing me the coordinates. Then definitely I'll come to cloud cover. I have to reduce the cloud cover because it's like I'm prompting it, and it's going to give me a result. So I reduce the cloud cover to like 5% because if there's cloud in that image, it will definitely disrupt what we want to do. Then I'll come to it. So that's just it, basically selecting anywhere in the world that you want to get. Then you come to data sets. Then, like I said, if it's digital elevation you want to, but we are not concerned with digital elevation. We want to use Landsat basically. So we'll come to Landsat here. So it's Landsat collection 2 level 1. Take note of it. If you use Landsat collection 2 level 2, it will not give you all the bands that you want. So collection 2 level 1 will definitely give you all the bands that you want. So let's move on. Collection 2 level 1. Then now is Landsat 8 I want. So I'll click on Landsat 8. Then I'll come, if this is telling me Landsat 8 to 9. OLI just means operational land image. That's like the criteria, the further qualifications of those Landsats, TIRS, C2, L1. All right, so I'll come to additional criteria. So this is where I can only specify it for it to give me only Landsat 8 data. So 5 is Landsat, so that I will not be wasting too much of my time. So I'll just come to these satellites, then I'll click on it, then results. So it's going to load this for me. Yeah, that's it. So definitely, So you have to this, let's say this is the area I want to download basically. So you have to be clicking on this footprint so that you know that the area you want is still covered. See, so that means that I can download this one. So far, this is the polygon I want, and this first one now is within the area I want. But then you have to check for some properties too. These are the things that you need to note when you are getting your spatial data. If not, just download the data and just see that you've wasted your data downloading the data that will not work basically. So it's very important to check the properties of your data. So after you've checked the footprint, then you come to metadata, show metadata and browse. So this way you have to check for the cloud cover basically. Yeah, so it's going to display the data here. So immediately looking at this data now, we see that some areas are covered with cloud. So I might not be able to use this one. See, the cloud cover is 4.96. I should still be able to go for the one that will be lesser than that. So let me check for another one. So scroll down. So I'll disable this footprint, check for this one. So this one still within the range. Then show metadata and browse. So yeah, see this one now compared to zero that 4 point something. So this cloud cover is 0.14, the land and the sim cloud cover. So it's still very okay. So definitely I can go for this. So if you want to download, you just click on this download button. Then to download all the bands, it's all the bands you're interested in. You select these product options and you select this. So this will give you all the bands. Do you get? So if I select it now, it will start downloading. So that's how to get your Landsat data. So let's proceed. All right, so let me move back to my ArcGIS Pro. So basically, me, I've downloaded the data. So the kind of application we want to look at is called the segmentation classification. So telling us that okay, in this particular area, I want to segment, okay, the areas that are water bodies, the areas that are built up, the areas that are vegetation, just for me to be to further understand, the image. Just for me to further understand, yeah, the image that I'm working with. So that is what we want to do. So use case of segmenting an image, basically, because mainly looking at this Landsat data now is kind of rough and I'm not really understanding it well. But so now, like, group it together. That is what it is used for. So then, like I said, I've downloaded the Landsat 8 data. So this is an area in Abeokuta North. I've extracted it. So this, okay, let me off this. Yeah, off it. All right, so this is my base map. I'm using the world imagery. Okay, then from the Nigeria map, our focus today is going to be Abeokuta North. Our focus today is going to be Abeokuta North. So I've extracted it, yeah, from the whole of Nigeria map. So this is it here, Abeokuta North. So definitely, so for this kind of image classification we want to do now, we'll be using three bands. So in spatial data, there's something we call force color composites. Okay, let me show you something. Let's come to map. Yeah, add data. So let's say you want to bring the data in, the data you've downloaded. So you come to map, add data, then browse. So then you will locate where you've saved it to. So this is where I've saved mine to. So this is the data, Landsat 8. So the idea is that Landsat 8 has 11 bands, but then all of those bands have their use cases. But for this kind of image classification I want to do, it is just three bands I'm going to need. I don't need all the 11 bands basically. So let's say I want to do another kind of application. There'll be times whereby I'll need the other type of band. But for this class, it is just three bands I need. All right, so which is band 5, band 4, and band 3. So it is that band 5, band 4, and band 3 I'm going to bring in basically. And why am I using band 5, band 4, and band 3? Because in spatial data, like I said earlier, there's something we call first color composite. So what does first color composite do? So first color composite would enable us, to visualize the image as it is in real life. So it is going to give us the red, green, and blue. I said it, I mentioned it in my slide here. Yeah, where is it now? Okay, can I see it now? So I mentioned it in my slide. If you go back to this slide, so it's called the first color composite. So it's going to give us the what? It's going to give us the red, the green, and the blue. So that is like the true way that image is actually represented in the real life. And for Landsat 8 data, to get that first color composite, we have to use band 5, band 4, and band 3. Let's say it's a Sentinel imagery we are using. To get the first color composite of Sentinel imagery, we have to use band 8, band 4, and band 3. They varies depending on the kind of satellite imagery you are using. But take note, if it is for Landsat 8, you are using band 5, band 4, and band 3. But if it is for Sentinel, you are using band 8, band 4, and band 3. So you can also check it online. Those information are online. So you can just type that, okay, oh, I want to do image classification using Landsat 8, using the first color composite. Give me the bands for first color composite. It will definitely bring it out. Band 5, band 4, and band 3. So like I said, I don't need all the bands. I just need band 5, band 4, and band 3. That is what you are going to bring in. And how can you recognize the band? So this one now is not expanding it, because of the it has shrink the. But if you just click it here, click one data. So for example, this first one now is band 1. This B1 means band 1. Then this second one is band 2. This third one is band 3. So definitely I need band 4. So I'll just click on it, then to input the 3 at the same time. Okay, this band 4, you can click on OK. It's going to bring it in, but me, I brought it in. That's why I'm not doing it again. I'm just showing you. Then band 5. Okay, so I need band 3 now. So after this band 5, you click OK. Then band 3, you click OK. Then I have them here now. So this is it. See, we have band 4, we have band 3, and we have band 5. All right, so let's move on. I hope we are still with me. Am I still clear? Am I audible?
Yes, you are.
All right, thank you. So, okay, so this is it now. So I'll just toggle it on. I'll toggle it on. Okay, so this is band what? Band 4. All right. So definitely, I'm having a specific study area. I'm not interested in the whole of the rest. This is my focus, for today. So definitely I'll have to clip out um this area, because definitely is not all the areas that I want to use. So I have to clip out this specific area. All right, so let's move on. So to clip it out, so you just come to your okay, yeah, so you just come to your geoprocessing and just search for clip. Then so definitely you come to this clip for data management, clip raster. That means that you want to clip this raster to this specific study area. So input your raster, you input your band 4, your output will be the shape file for the study area. That's Abeokuta nodes. Then you come down, you toggle this on, then you will run it. But me, I've clipped it, so I'm just showing you. So you run that clip 3 times. You run it for band 5, you run it for band 4, and you run it for band 3. All right, so let's move on. So this is my clip now. This for band 4, this for band 3, and this for band 5. So as you can see, the rest of the imagery has gone because this is our study area. So like I was saying now, so to proceed now, so there's something we call the first color composite, like I've explained earlier. And the idea now is that we want to join band 5, band 4, and band 3 all together, give us the first color composite, and we will see the beauty of it now. So to do that, you come to your geoprocessing tool once again, then you search for composite. Yes. So definitely composite bands, meaning that I want to create a composite band out of band 5, band 4, and band 3. And what does composite band mean? Composite band is just like composite. It's just the process of joining two or more bands together to give us a single band. So I'll click on composite, then see input rasters. Then I would input, that's the clips now. The band 5 first off, then the band 4, and the band 3. So everything now is going to turn to a single band. So all right, so this is the output raster, and I'll run it. So we'll see it now. Good. All right, so can we see it? Okay, so let me toggle off the clips. We don't need them again. Okay, so this is the composite now. So like I said, it is showing us the true imagery in red, green, and blue. See, red, green, and blue. So it is showing us the true imagery of the true way the image is represented. And the main reason why I used, one of the beauty of using ArcGIS Pro is that you can see the base map. You can use different kind of base map. So I'm using the world imagery base map. So see now, it has segmented it for us, basically showing us that this part, you know if it is a sentinel imagery, it might be much more clearer than this, because the resolution of sentinel imagery is much more higher than Landsat, but then this is still fine. So like I was saying, it tallies with the world imagery. Let me show you something. So if I toggle this off, so see what the world imagery is showing us. It's showing us that this part now is built up. Basically there are buildings here. So let me toggle it on. You see, there are buildings here. Let's come to this line, because it is in red, green, blue, so it is showing us the actual colors of the way those features are represented. So see there's a line showing the water line here. See, same with this one too. See, if I toggle it on, you see that it's the same. And definitely the vegetation too, all these parts. Let me increase the brightness of my screen. All right, so definitely the vegetation too is also represented too. So that is the beauty of using first color composite when you are carrying out your image segmentation and image classification. So using your band 5, band 4, and band 3, it is going to show you the way it is actually represented. Okay, just for learning purpose, let me show us a sentinel imagery too, but this is a different area in Nigeria. So this, sorry about that. All right, so this is a sentinel imagery, a true color tool for these are Akure North and South in Nigeria. So if I toggle it off, see it is showing us where they are built up, like I said, where there are water bodies. See this line is water bodies. All these places, they are built up. If I toggle it off, we'll see that it is true with the base map, the base map imagery that ArcGIS Pro is giving us. So that's just the beauty of using it. So let us continue with this one that we've clipped. Okay, this is it here. All right, so let's move on now. So the next thing to do now is that, so okay, we can now visualize it now, but I want to group all of them together. I want to ensure that this is all grouped together, because this is just still a satellite imagery, and I have to show that, okay, all this built up area, they are one. All these water bodies here is also one too. This vegetation, and also I'm seeing some bare lands too that are here. It is one, and the way it is just scattered there on this satellite imagery. So that is where the use case of our pixel. So basically everything we've been doing so far is just preparing our image for using the pixels that we want to apply now. So we've prepared the image now. We already have our first color composite and want to continue. So the next thing to do now is to come to the imagery, the imagery section here in ArcGIS Pro, because it's like we want to work on this imagery. So you have to come to this imagery, then I'll click on classification wizard. Yeah. So I'll use the classification method. Like I said, I want to classify these images. I want to classify the water bodies. I want to classify the built up. I want to classify the vegetation, and um so the classification method I want to use is a supervised method. I explained it in the last class. So we have the supervised and we have the unsupervised. So what supervised, the advantages of using supervised is that we'll be able to input the we'll be able to train the algorithm ourselves compared to using the unsupervised. What unsupervised will do is just that unsupervised will just do it based on his discretion. Unsupervised will just be like, oh, um I'm seeing a built up here, let me group it together. I'm seeing water bodies here, let me group it together. So it's just based on the system discretion. That is what unsupervised is going to do. But supervised is the recommended way, because we are geospatial analysts, we are geospatial scientists, we know about this thing. So I can definitely know that, okay, this is a water body, definitely I can group it together. This is vegetation, this is built up, rather this is vegetation. So I'm basically doing it myself. That is why it is called a supervised method. Like I'm supervising it by myself. So I'm using the supervised method. Then the classification type, if you can recall too, we have the pixel based, we have the object based, but our focus for now is the pixel based. That means that we are classifying it based on the individual pixels. See, if I zoom in, we'll be seeing the pixels. This is what I call the pixels. See, these small boxes, they are the binary that I was explaining here. The binary, these small boxes, these are the pixels. So it is this pixel that join together, that come up together to make up this whole imagery. So these are the pixels. If I zoom in, so these are pixels, yeah, pixels. All right, so let's move on. So the calculation type once we are using is the pixel based. All right, sorry about that. So the classification type we are using is the pixel based. So let's move on. So because it is the supervised method, we have to train this image by ourselves. We have to train this image by ourselves. That is where this training samples comes in, because I'm the one supervising it myself. So what that training sample is just doing is just that I'm telling you that, okay, I'm seeing I'm seeing a water body here. So I'm giving the algorithm that, okay, classify this area for me as water body, classify this area for me as built up, classify this area for me as vegetation, classify this area for me as bare land. So that is what I'm telling it basically. So that is the essence of creating training samples. All right, so that is that. We've come to the imagery, then image classification wizard, then the supervised, then we've clicked on the pixel base. But before we can proceed, we have to use our training samples. Then we'll come to classification tools, then come to training sample manager. So you select training sample manager. So I want to train it myself, because it's like I'm supervising it myself basically. So training sample manager, then I'm going to now come here. I'm going to click on create new schema. Yeah. So what this is just saying is just that, okay, I want to select the number of classes I want to train basically. So all right. So new schema, then I'll right click on it. I'll click on add new class. So definitely, like I said, in this area, I'm seeing a water body. So the first class I'm going to give is water bodies. Water bodies. So I'm going to give it a value of 1, and I'll assign there's something we call cartographic colors too in spatial data. So what cartographic colors just means is that you're representing a particular the features on the earth surface with a specific kind of colors that is accepted in spatial data analysis. So water bodies now, we represent it using like water bodies that is not contaminated. We represent it using the color of like a light blue color. So let me use this. All right, then I'll click on OK. So I'm also seeing some built up here. I'll add another class to this schema, add new class, then the name is built up area, built up, then the value is 2. Then built up, we can use something like brown, yeah, in cartographic colors to represent a built up. So let me use this. Okay, then new schema, I'll come to new schema, add new class so I can see some vegetations too. All right, so I can see some vegetation. So then the value will be 3. That's the third one. So vegetation, let me use green. Okay, then I can also see some bare lands too. So that will be my fourth classification. So sometimes you just have to compare it with the real world imageries. That's the advantage of using ArcGIS Pro. Like I said, it's giving you the base map of of the world imagery. Okay, so let me add new schema, new class. So let me do Bearland. That will be 4. So Bearland, I can use something like I can use okay, Bearland should be use gray. All right, so let's move on now. So we have created, like I said, we have where is it now? Okay, so we've specified the classes that we want to group this image into. So the next thing now is that it's still training samples we are creating. So I'll click on this. We can use a rectangle, we can use a polygon. So what I want to do now is that, okay, on this imagery we want to now group the all these classes together. So I'll start with the water body. So I'll click on water body, then I can use a polygon. Then I'll now come to where I'm seeing water bodies in this imagery and be drawing these polygons on them. So I'll be drawing the polygons on them. See, as we are drawing them, it is reflecting here. So we have to be very careful so that it will not enter into another pixel. So you have to zoom in and so this is another one. It's not necessarily that you must be doing it closely. What the beautiful thing about the algorithm is that so far it is seeing same. You've done one year, you've done one year, it is seeing it as the same already. Then you can go down to pick another one, then go down also to pick another one. Okay, I can pick another one here. So by this, you are creating your man, you're basically using the pixels because it is the pixels I'm zooming into, to create these training samples and to group them together. Then let me pick another one here. So as you can see, as you are creating them, is reflecting here. So we can use it to track the number of training samples that we are creating. Okay, so let's go. So that's why it is called a supervise. It's like I said earlier, I'm supervising it myself. So let's move on. All right, so I'm seeing, so I can just pick one here since it's the same water body. But the truth is that so far I've drawn this one, it will definitely see this one too as part of it too. But let me just zoom in and just pick one here. I can pick more than one, but because of our time, let's. All right, so let's move on. So definitely I'll move to build up. Oh, I misspelled this built up, built. Okay. All right, so let's move to built up. Same process too. I'll click on the polygon, and wherever I'm seeing built up here, I would draw my. So there's also some part of built up in this area. Okay, if you can see, some built up here are mixed with the vegetation that is here. So there are also some here. I can just zoom in closely into the pixels to pick them, to pick it. All right, so let's continue. So there's also some here. So that is what is called training samples. Like I'm training the algorithm myself, like I said earlier. So okay. So okay, let me pick some more for built up. So let me just pick like two more. I'll move to the next one. All right, so let's continue. Okay, so if okay, I'll show us later. So let's move to the vegetation. So as you can see, vegetation is what is dominant here in this environment. The vegetation is dominant. Although we can still further classify this vegetation to, let's say, forest, but then because of the resolution of this Landsat, we might not be able to see it well, compared to imagery that have like the Asta or Sentinel images that have higher resolution. So but let's just use the vegetation. So I'm currently on the vegetation now. So I would be drawing the polygons on the areas. Okay, so the vegetation is kind of mixed in this particular area. So that is why it's very good, to be verifying it with a word imagery that you have, because so that you not get confused, and one has to just understand the image very well, before you can start to be able to segment it and classify it very well. All right, so I think let's work with that for vegetation because of our time. Then the next one is bare land. I'm seeing some bare lands in between those vegetation. So these are this one. So we can, so they are like mixed between the vegetation. So let's work with it. So is this color? Okay, so okay, these are some balance to mix with the vegetation. So just always recall, it's very just important that you understand, the imagery that you are working with first before you even start anything, before you start working. So just understand the imagery that you are working with. So this is the balance. All right, so then you can pick more than that. Actually, it depends on, the more you pick, the more accurate it's going to be. But for the sake of this class, let's limit it to this. Let's stop here. So the next thing, so you are done with your training samples now, so you have to merge each of those classes together. So all these water bodies, you just select the water bodies, then come to the last one, the last water bodies we have. You click on shift, like you want to select everything together, then you merge everything. Click here, collapse. You collapse the, okay, we still have two, so select it and select your shift for the second one, then you collapse it. Yeah, same with the build up. Select the build up to the last one here, up to the last one. So we even still have some water bodies, so you collapse it. Okay, then your build up to the last one, then you collapse it to, same with your vegetation, up to the last one. Click on shift, you collapse it. Then finally your balance up to the last one, then you collapse it. Okay, there's still three. Click on shift, then you collapse it. All right, so that's it. So the next thing to do now is that, okay, we created our training samples. That is what we are going to use in the classification. So we have to save it. So you click here, you come to save your training samples. You save it in the current folder you are working on. So you just save it, training samples. I have a training samples here before that I've worked with. So let me just use it as training samples too, so that it's not confuse me. All right, so I've saved it definitely. So I can now return back, to my classification wizard, the supervise, the pixel base. So the classification schema, meaning that I want to use the classification schema. Mean if I'm using a non-supervised, I will not need the classification schema. But now that I'm using a supervised, that means that I'm telling them that it is the training sample that I've used. That is what is going to be my classification schema. That is what you are going to use to classify the imagery. So I'm going to select generate from training samples. So I'm going to, okay, let me refresh this. All right. So I'm going to create the training samples that, I've created. Click on OK. Then optional, I have to select the training samples, the training samples that I've generated. Yeah, this is it. Yeah. So then I'll click on next. All right, so this is the training sample manager that we did. Click on next. Then I want to train it now. So this is just where the algorithm comes in now. So all these algorithm actually, they are, they are embedded in the software. It is ArcGIS Pro. So what it does is that it just run it underground based on the one that I want to use, and it's going to give us the result. So the one that we can use to give us the best results in all of them is say using the maximum likelihood. So what does the maximum likelihood does? Because we've created trading samples, so what maximum likelihood is going to do is that maximum likelihood, you just ensure that everything looks familiar together with each other. That means that all the polygons we've created on the each of those classes, it is going to see them as one, and going to now give us the classification the way it's meant to be. So I'm going to select maximum likelihood and select run. Let us give it some time for it to run. All right, can we see the final output now? So you see that it does not even take time, although depending on the imagery we are using. So that is just it basically. See, it has given us the water bodies, it has grouped them together. The built up, it has grouped them together. The vegetation, it has grouped them together, and the bare land, it has grouped them together. Then we can reclassify it basically just to further improve the accuracy. So you just click on this one was train. Then you click on this next button here, which is classify. Then the classifier we'll use is the output that we just got, which is this, and we'll run it again. So you're just going to reclassify it again based on the algorithm, based on the way the algorithm has classified this before. All right, so that's it. Then all right, so that's a use case of pixel based image analysis. So like I said, we've been able to group those um um those features together using the pixels. It's the pixels we used. So we've been able to group them together and using the pixels, and they are all grouped together. So presenting this imagery now, we've transformed the Landsat imagery now, the way it's just scattered. It has helped us for group it together, tell us that okay, all these ones they are built up, all these ones they are vegetation, and showing us the bare lands too and the water bodies in that particular area. So that is just the use case of pixel based image analysis. And using the slide, we can further check the other use case of other practical applications of pixel based image analysis, and there's even object based too. And that's it for now. So thank you so much. I think I can entertain questions now, and thank you for staying through. Ricky, over to you. You can get questions now.
Okay, thank you, Ajibola. Thank you so much for this powerful training. Thank you for explaining. Thank you for taking your time to explain from image acquisition to the analysis itself. So I see we have a question from Daniel. Hello, Daniel. You can go ahead.
All right, thank you very much, Abidola, for that wonderful presentation. So my
Yeah, well,
question is, when you were picking training data set to classify water body, I realized
okay,
that I realized that when you finish picking training data set on that, should I say on that main water body, there's a tiny
okay.
water route
Yes,
around
yes.
the edge of that. Why did the model not like pick that place
And
as water body?
yeah, I
Is it because
noticed
you
it
don't have
too.
enough? Is it that because you don't have enough training data sets in that
Training
area?
sample,
Or
that is just the reason actually. That's why it is called the supervised. You are the one training it yourself. So I think
uh,
the reason was because I did not pick enough on this line. That's why it is seeing it as the other one basically. So you
okay,
have someone
but
has to be very key. That's why I was okay.
Okay, but in that case, because I know if it was a normal pure machine, there's a way you can increase the number of training data sets to better increase the accuracy of your model. But in this case, where you see that maybe your model is not doing very well or is not that
Yeah,
accurate as much as you want, is there a way you
yeah.
can increase the number of
So
training data
Eddie, definitely you
sets?
can come back. You come back to the training samples. You have to come back to the training sample. No, you disregard this one, then you come back to the imagery. You come back to the imagery and you can still edit it actually. You just come to your
Okay,
training
okay,
samples, come
all
to
right,
classification.
all right, all right.
Yeah,
Thank you
I
very
want to
much.
show you.
Thank you.
You come back to your training samples and we can still edit. You can still add more to it basically. Just come here, but you have to run the classification again after you've added more to it. So see, I can still add more to it. You see, but then when you now merge it together, you have to run the classification again. You will save the training sample and you have to run it again. Do you get me? Hello.
Understand you. Thank you very much, Ajibola.
Yeah, so you come and edit the training sample just like I did, and you made it again, and you have to run it again.
All right. All right. Thank you.
Thank you. Mm.
So thank you for your question, Daniel, and thank you, Ajibola, for responding to him. So, do we have more questions on this session? Okay, I guess we do not have questions. But thank you so much, thank you so much, Ajibola, for this training today. Thank you. I know that
You're
it's a
welcome.
lot
Thank you.
to come back on this platform and carry out practical sessions from like a follow-up session from the previous session, which we were not able to finish up. Thank you for giving us your time. We appreciate your experience and expertise, which you have shared with us today. And we look forward to having more sessions with you because I know in the past session you mentioned something on object-based classification analysis. So I'm hoping that maybe one of these days or whenever it is that it's convenient for you, you tell us when you would like to take us on that.
Sure, no
But thank
problem.
you. Thank you for this one. Thank you. We appreciate your time. And thank you to everyone who made our time to join the session today. And this recording will be made available on our YouTube page, and it will be mailed to us. The link will be shared to us via email. So thank you, everyone, and enjoy your weekend. Have a very, very good weekend.
All right.
Thank you.